I think I saw him in, I'll call it the precursor to this group. I think it was under the same name, but many, I don't want to make him sound old. That's bad. Many years ago there, and he's continued to join us. I'm guessing that you all read, and I've been told not to read slides, so I won't say too much about what we have here on the screen, but he has a lot of experience. He cares about software. He cares about the quality. He's an excellent .NET developer, and we are very pleased to have him. So with that, we'll just jump in, and we will let him share his screen and present for us on C# and its next or current iteration. So John, you want to go ahead?
Yeah, thank you, Caleb. It's okay. You can call me old. I'm coming.
I don't
to terms
think you're
with
any older than me. I might look younger. I might not. I don't know, but okay. And we are live streaming now, so you are good to kick off yourself with any introduction that you'd like everybody on YouTube here to see.
Okay.
And thank you. I will probably mute and kill video unless there's questions or things like that that pop up. That way it's less distracting for other people who have a single window and the chat on their screen. But feel free to take this in the direction that you've planned, and we'll go from there.
Okay, and since we're recording and streaming, I'll make sure not to say anything stupid. Embarrassing. Yeah, welcome to this meetup and to this presentation where, if you didn't already know, we're going to talk about C# 9 and 10 features. So if you are the kind of person who has been following the latest in C# closely, this might be a review for you. But hopefully, hopefully it'll be a good review. If you haven't been keeping up on the latest, all the super latest C# developments, hopefully this will be a nice sort of like overview of some of the big ticket items for you, at least anyway. Let's see. As you'll probably be able to tell here, I'm using Visual Studio Code as my presentation tool because I'm nerdy like that sometimes, and I assume the rest of you would be hopefully sufficiently nerdy to appreciate it. I also have a little thing down here at the bottom that shows like keyboard shortcut things. I thought that might be useful for people, but if it gets in the way and you want me to turn off, just let me know. A little bit about me. I work at a company called Immersion. I write code there mostly. If you're not familiar with Immersion, I wouldn't be surprised. It's a fairly small company, but we do automated online language proficiency evaluations. So you go to a website and it tells you some words and you say words back to it, and it tells you how good you are at English, that kind of thing. If that sounds interesting to you, feel free to check out the website or talk to me about it. I'll do the obligatory. We are hiring, so if you are interested in, if you happen to be looking and are interested in places that do things like mob programming and test-driven development and deploying to production multiple times per day, go ahead and check it out. You can. I didn't put a link to our job posting there, but you could probably find it. Or if you can't, again, feel free to contact me. Have a couple links there for my email and LinkedIn. If you like, if you're one of those people who likes to message on LinkedIn instead of email, that's cool. Or if you want to connect with me, that's also cool. I put a couple other links here. I put a link to the Utah Software Craftsmanship group. That's a group that I co-organize. We meet on the first Wednesday of every month. Yeah, I think that's right. If you want to hang out with some people who care about like code quality and how we craft our code and things like pair and mob programming and test-driven development and continuous delivery and stuff like that, feel free to join us there. You can go to the website and get the details for the meetup. We also have a Slack group. You're welcome to join that. I'll also put a link here to the Salt Lake.NET user group. Presumably, since you're here, you know what that group is. I did put a link there, though. There is a Slack group for it if you happen to not be on that yet. We occasionally have good conversations there. And lastly, I put a link to my personal website. If you want to go see like weird, mostly ASCII-based games that I've written, or read my blog or something like that, feel free to do that. Also, so I have a couple of these markdown documents that we're going to look at to start with, but most of this presentation is code, and it's all in a GitHub repo. And I posted the link there, or if you're one of those cool kids who can scan QR codes on your phone, I have that here also. Okay, so we're going to go to here. So we're going to talk about C# 9 and 10. C# 9 was released in 2020. That's supported in .NET 5 and above. C# 10 was just released this last November in 2021, and it's supported in .NET 6 and above. .NET 6 is an LTS release, a long-term support release, if that is important to you or the company where you work. You will notice that neither C# 9 or 10 are supported in any .NET framework versions. That's unfortunate, but kind of understandable given the direction that Microsoft has been taking with .NET lately. I did go as far as Googling to see if you could like hack to do some sort of hack to make the C# 9 or 10 compiler work with older versions of the .NET framework and stuff like that, and you maybe can, but I don't know. Officially, it's not supported. As I mentioned a minute ago, I'm going to go through what I think are some of the biggest, most important features of C# 9 and 10. Microsoft does have a really good list, a good web page in their documentation of I think all the features, a bigger list of features than what we're going to have time to go over this evening. I put some links there to those, so feel free to check those out. Also, if you want to review some of the new features that were introduced in C# in older versions of C#, I think the Microsoft documentation goes back to 7, maybe 6, but at least 7, I know. So if you like a list of features in a web page kind of format, and you want to review C# 7 and 8 features as well, I would also recommend that Microsoft website. If you like this sort of format where it's more code and you can play around and interact with it more, again, this code is a GitHub repo, but I also have another GitHub repo that's for C# 7 and 8 features if that's interesting to you.
Hey, John, I just want to let you know I pasted the actual link into the chat for that awesome. C# 7 and 8 repo.
Thank you. That way I don't have to manage my clipboard while I'm presenting. Thank you. That makes my life much easier. Okay, so that's sort of what we're going to talk about. We're going to start with talking about C# 9. We're going to talk about C# 9 and then C# 10. I decided I wanted the Microsoft pages that I mentioned. They have code samples, which is great, but it's not actually executable code. And I was like, well, it'd be super awesome to show these features in actual code, not as slides and things like that. I want to make sure that it's executable code. I also want to make sure that it is correct and that it works every time, right? So, I mentioned that I help organize the Utah Software Craftsmanship Group, and one of the things we talk about is test-driven development and things like that. So I was like, oh, how about I implement all this as unit tests? So that's what I did. That's the format we're going to do here, and I can come over here just to prove to you. I have apparently 22 tests, and they do all pass. So as we're looking at code, you can be like, and you're like, wait a minute, that looks dodgy. Code does compile and does pass and all that sort of stuff. So in C# 9, we're going to talk about some init only setters and top level statements and some pattern matching stuff. And then there's sort of a miscellaneous bucket of a few other random things. And then arguably the largest feature in C# 9 is records. So we'll talk about that last. Sort of one of the themes of C# 9 is immutability. If you're not familiar with immutability, it's the idea that you make a thing that has data and stuff, and then you don't change it again. You can make a copy of it, but you don't change it. Immutability has a lot of desirable properties, like it works really well in multi-threaded scenarios and things like that. There are also some challenges. C# you've always been able to do things in an immutable way, but it hasn't always been the easiest to do. So there are several features in C# 9 that make it easier to do immutability. The first one we're going to talk about is init-only setters. That's one of the things that makes doing immutability easier. So we come and look at some code. You've always been able in C# to create a class like this one. If I come and look at it, you can see it's a class that takes a parameter in the constructor and then sets some field that using that value that you then expose via a property, right? You've been able to do that for a long time. And that's one way you can do immutability, but it's a little bit, I mean, it's fine, it works. But it does have some drawbacks. For example, if you only have this one constructor, then you have to pass those parameters in the constructor. That can be annoying sometimes. You also can't do things like this with object initializers, right? Because you're setting that value by supplying a value in the constructor, and that property is read-only, so you can't change it later, right? So in C#9, they introduced a way to do that, I would say maybe better, or at least different, and it's called an init-only setter. And so, oops, oh, here it is. So here is an example of an init-only setter. You can see it looks just like a normal property, but instead of saying get and set, I do get and init. And what that does, it makes it, you can still set the property, but you can only set it in the constructor or with an object initializer. So it gives you an additional option to set it in an object initializer like this. So that can be kind of nice. It is read-only. So like if you try to set it after the fact, after you've already constructed your object, you can see I get an evil red squiggly here. As I mentioned, you can set it in the constructor. You don't have to though. You don't actually have to set it anywhere. And if you don't, then it'll just have whatever its default value is. So like in this example down here, I don't ever set that property. And so it just has whatever the default value for that property type is, which in the case of integers is 0, right? So this is kind of cool. It makes it a little bit easier to do read-only properties that are a little bit easier to work with. It gives you a few more options and stuff like that. So that's kind of nice. That's a nice feature. Next one, let's talk about top-level statements. For this one, I'm going to come over here to another file. I didn't actually do this one as a test. If you have ever created a brand new C# console application, you've probably seen some code that looks a lot like this commented out code here, where you probably have one or more using statements up here. You have a namespace, a class, a public void main, and then finally in here, indenting 3 levels, you can finally start, print out, do your console write line or whatever, right? And this is fine, it works. There's nothing wrong with this necessarily, but there are a lot of other languages, not all languages, but there are a lot of other languages where in order to just get something like the printout on the screen, you've had options to do that with a lot less boilerplate code, right? Like all of this stuff here. And so in C#9, they added this idea of top-level statements. So you can see up here in my actual code, I have a using statement and a console write line. I don't have any public void main, public class program, no namespace, nothing like that. And if I go to run my code, you can see it prints out. This is a top-level statement, which comes from this line right here, right? This is a nice way to, in your main.cs or program.cs or whatever you call it, it's a nice way to be able to start running some code without having to do all this extra boilerplate stuff here. Now you may be thinking to yourself, well, but I can't just like start putting C# statements anywhere and just have it run magically. There are definitely rules around this. For example, you can only have, so this top level statement file here, you can only have one of those in your project. If you have more than one, you'll get a compiler error. Or if you have one of these top level statement files and somewhere in your code you have a public void main, method that the compiler recognizes as an entry point, that will also result in a compiler error. So I don't know about you. For me, most of the code that I work in, day to day for my job, I'm not in a program.cs file or something like that. For most of it's, some bootstrapping happens there, and then all the rest of the code is in other places. So for that type of code, this probably won't, revolutionize how you work. But for simpler programs or example programs, or if you're going to do like a workshop or a training or something, this type of top level statement could be a nice way to help introduce people to C# or get them familiar with new concepts without having to have quite as much ceremony. So, that's cool. It's a nice addition. It may or may not revolutionize your life, but it is a nice addition to have. Okay, next topic is, let's talk about pattern matching. So Microsoft introduced pattern matching in general in C#7, I think it was. And when they did, it felt kind of, I don't know, to me, it felt kind of half-baked, like it was, well, we have pattern matching, but you can only use it in these one or two ways. And then there were a couple different C#7 versions that they added more pattern matching in most of those versions. And then they add more pattern matching in C#8. And now in C#9, they're adding yet more pattern matching. The couple of things that they've added for pattern matching in C#9, they've added and or patterns. So for example, here I have some tests, and I'm calling this local function. So if you're not familiar with it, a local function is a method that is scoped within another method. This is a thing they added in C#7, I think. Anyway, so if you're not familiar with this, and this one happens to be an expression-bodied local function. So if this syntax looks a little weird to you, just know that it's a method that can only be called within this other method. So for this method, you pass in a character, and it will tell you if that character is a letter, and it does that via pattern matching. There are other ways you could do this too, but I wanted to use this as an example. So it says C is, which is starting your pattern, and then I'm going to put some parentheses in here. I didn't put them in here to start with because the syntax highlighting gets weird. I don't know what's up with Visual Studio Code, but it gets weird with the syntax highlighting here. I don't know why. But you can see I want to make sure that C is greater than or equal to lowercase a and less than or equal to Z, or greater than or equal to capital A and less than or equal to capital Z. And so these are doing pattern matching, and I'm combining them using and or. For me, this, like, when I saw this, I was like, oh, yeah, that totally makes sense. Why would you not be able to do that? But it's different than Boolean and or, what it works with. It works the same. It just works with patterns instead of with Boolean values. So that's cool. And or patterns. Similarly, they also added a not pattern, so you can negate another pattern. The one that I think, the example that I think is really great for this one is you can finally write a null check that actually reads the way you say it. If object is not null, instead of at this point I've rewired my brain so that a bang equals null. I just parse that into English, but it's nice to be able to write it in actual English, right? You can use this anywhere where you use a pattern. You don't have to just do it in if statements like this, but I just did it in if statements because it was easy. So that's cool. A couple more pattern matching things. The pattern matching is in C# is getting more full featured and more useful. That's pretty cool. Now for the potpourri miscellaneous section. This is a couple other things that I thought was like, oh, that's kind of cool, but it didn't fall into as good a category as some of the other ones up above. So the first one I want to talk about is target typed instantiation. So for forever, like back in the old days, the bad old days of C#, when we made a new object, we'd have to do something like this, right? We do class name, variable name equals new class name. And it was terrible and we all hated life, especially if this class name got really long, then, you know, that just creating a new object could be a very long line of code. And that could be cumbersome. In C# 3.5, somewhere around there, they added implicit typing of variables. So you could use the keyword var. So here you use the keyword var and then your variable name equals new and then the type name. And the compiler is smart enough to figure out what type this is. So you type in the word var, but it figures out that it's really, in this case, a my type object. So that was cool. Similarly, in C# 9, they made the compiler still smarter so that instead of just being able to figure out what the type is on the left side of the equals, it can also figure out what the type is on the right side of the equals. So this is kind of like the example up above, but instead of implicitly typing on the left side here, we're implicitly typing on the right side here. So here we do class name, variable name, and you can just say equals new, and it will figure, the compiler is smart enough to figure out what the type is there. So that's kind of cool. I haven't decided for myself personally how I feel about this. If I'm going to start writing my code more like this, or if I'm going to keep doing this, you know, the implicit typing on the left of the equals. Haven't really decided. I need to do some more, you know, personal introspection, see how I feel about it. But it's a nice option to have. And if you're wondering, you of course can't do implicit typing on both sides, because, you know, then the compiler has no idea what type you'd want it to be. So you have to give it a type somewhere. So target type new, that's cool. You can use it here in this example. I was using it just for instantiating new objects when I'm, you know, when you're setting an object reference. You can use it in other places too, like if you're passing something to a method, you can use it anywhere where you could use that sort of object, right? One thing that I thought of when I was first reading about this is I thought, oh, that'd be super great for default parameters on methods, right? Where you have a method declaration like this and you give a parameter a default value. Unfortunately, you can't use it in this situation because default values for parameters on methods, they have to be compile time constants. And since here we're creating a new object, it is not a compile time constant. So can't do that. You can combine target typed instantiation with object initializers. They'll still work just fine. There's nothing special there. So yeah, that's cool. So that's target typing. Another thing that we're going to talk about is static Lambda expressions. So in C# 3 or 3.5, somewhere in there, they added the idea of lambdas, right? Like you can have this little piece of code in here that then you pass to a method or something like that, that it can then execute it, you know, at some later time, even if it wants to. Those have been around for a long time. One of the powerful and terrible things about lambdas is that they can capture locally scoped variables. So for example, in this Lambda expression, you can see I'm referencing this some locally scoped variable, which is declared here inside this method. This where method, it could take this Lambda expression, and I don't really know when I don't have any guarantees about when it will execute that code. It could execute it immediately, or it could, you know, spin up a thread and wait for 20 minutes and then execute it, you know, 20 minutes from now or something like that. I don't really have control over it. A lot of times that's totally fine. Sometimes that's even what we want, where if we change this variable later, you know, if we change this variable at some point after we call this where and pass it a Lambda, then that change will be reflected when this Lambda gets executed. Sometimes that's what we want. Sometimes, however, that's not what we want, and it results in unexpected behavior. Because we think, oh, well, I called this where method, and so obviously that code in the Lambda got executed. Well, not necessarily. And so sometimes you want to make sure you are not capturing any of these locally scoped variables. And so now there's a way with the compiler that you can explicitly say, hey, I'm never going to have locally scoped variables in this Lambda. Not just trust me, I promise I'm not going to cheat. It's no, I cannot do it because the compiler won't let me. And you do that by adding the keyword static to your Lambda. So this Lambda expression here can't capture any locally scoped variables. So for example, here I have this one commented out. If I try to run it, then the compiler is like, nope, sorry, this is a locally scoped variable, and you said that you promised you wouldn't use any locally scoped variables, so I'm not going to compile because you broke your promise. So that's nice. Like, again, this is one of those things that for me probably won't revolutionize my code, but it's a nice option to have. Okay, so that's static Lambda expressions. Oh yeah, go ahead.
I have a question about that. So, I mean, it's clearly smart enough if you've got a literal value or a constant value there. But what if instead of having some locally scoped variable, you have a locally scoped constant? If it's a constant, will the static still work because it's then able to hard code that in when it compiles?
I don't know. That's a great question. Let's find out.
Well, look at that.
Well, look at that. It's smart enough to know that it can do that. Apparently, you can use locally scoped constant variables.
So that seems like that's awesome because now you can get away from the magic number 3 being in your code. You can name those as constants and still have it compile in on a static Lambda. That's great.
Yeah, that's interesting. Thanks for the question. I hadn't thought of that case. That is I'm glad that it works the way that it does for that one.
And we've got a what about static read-only variables is in the constant. So we can try that if you want.
Yeah, sure. Can you make it static here? You can't make it static here.
It may have
to inside.
It may have to be outside, huh?
Yeah. If it's out here, then I'm pretty sure you can do it because it's not locally scoped. But let's find out. You're not really supposed to do this in a presentation because something will go wrong. But oh, interesting.
Yeah, it doesn't like the equals. It looks like either up there.
Your variable needs a type.
Oh, thank you. See, this is why you're not supposed to do this in presentation because you'll type something wrong like this. Okay, so then it's okay. That makes sense. That makes sense because this one is not locally scoped. Okay, interesting. Yeah, thanks for the questions. Yeah, this is one of the advantages of having it actually be real code as opposed to just a slide or something. Then we can go and find these things out and we can know. Okay, so that is static Lambda expressions. Some cool stuff there. Go and play with them some more if you have some other scenarios you want to try out. Let's talk about for each for a minute. So in general, in order for something to work with a for each loop where you iterate over it, it needs to have the class of this object here needs to have a get enumerator method with the right signature. But if you look at this class that I have here, you'll notice it does not have a get enumerator method of any kind, regardless of its signature. However, it does have something that probably makes sense to iterate over. Now, this is kind of a contrived example because I could just do, here I could do object dot something to iterate over and iterate over it anyway. But I did it here for simplicity purposes. Anyway, so this class has something that maybe makes sense to iterate over, but it doesn't have a getEnumerator method so that it will work with a for each. In C#9, you can now, that getEnumerator, instead of being declared on the class, can now be declared as an extension method. So if I come down here and have an extension method, you can tell this is an extension method because I use keyword this, and then the type that I'm extending. If as an extension method, you have a getEnumerator method that has the right signature, then you can use for each to iterate over this this object type, even though it doesn't implement its own getEnumerator method. So that's kind of nice. Like if you have some class that you're pulling in from a third-party library or something, and you can't modify the code, but you want to be able to iterate over something about that, but it doesn't have a getEnumerator, you can now add that and make it a little bit easier to work with. So again, this is probably not something that's going to revolutionize the code that I write day to day, but it is a nice thing to have, and maybe it will revolutionize your code. I don't know. So that's sort of our potpourri section, our miscellaneous section. Now I want to talk about what I would argue is the largest single bucket of features for C#9, which is records. So let's talk about records for a minute. So I don't know how your code is. In my code, most of the code that I write, there are places where I just want to have a simple class that holds some data. Maybe it doesn't even have any behavior in it. Maybe it has a little bit, but maybe it's just a class that holds data. Some people call these like DTOs, data transfer objects, or POCOs, plain old C# or CLR objects. This happens not with every type of object, but it happens with some regularity in the type of code that I write, at least. Maybe it does in your code, maybe it doesn't, I don't know. In my mind, records are a great option for this type of situation. Records are a great way to do a quick and easy, hey, I just want this thing that holds some data. It can have behavior, but it's kind of, it's maybe not geared towards that, though it totally can. And it also has, records also have some nice immutability features. Remember we talked about immutability at the beginning. So let's start looking at records. So the first characteristic of records that we're going to talk about is an option to have what are called positional parameters. So if I come look at this class, well, this record here, excuse me, you can see I use the keyword record and then the type name. And then for this positional parameter idea, I just do parentheses and then type name like this. And I get a couple of, by doing, and this is the whole definition of this record. You can have record definitions that are longer than this, but this is a nice simple example. You'll also notice the syntax highlighting doesn't work quite right here in Visual Studio Code. Again, I don't know why that is. So this is my entire record definition here. And when I do those parentheses and put in the type name, it gives me a couple of things. The first thing it gives me is a constructor that takes values for those parameters. So if you remember here, I had a string first and then an integer. So I automatically get a constructor that takes a string and an integer. And it will take whatever string value pass in and assign it to that string property that I declared. And it will take whatever the second thing is, the second parameter is, and assign that to that int property that I declared. So that's with positional parameters on records, that's the first thing you get is a constructor that takes all the arguments that you declared for as positional parameters and then also automatically assigns them for you. So that's really nice a really nice way to quickly and concisely define hey, I just want this thing that holds some data. Those positional parameters are immutable. They're read-only by default. So if you try to set them afterwards, compiler will be like, nope, sorry, positional parameters read-only. You cannot change it afterwards. So in addition to getting a constructor and those read-only properties, you can see here I'm accessing those properties, reading them as opposed to setting them like I was doing here. So you get the constructor, you get properties, but wait, there's more. You also get a deconstruct method. Now this is a deconstruct method, not a destructor method. They have almost the same name, but are totally different. We'll see just a little bit more about deconstruct methods with C#10. They added a little something there too. But they added the idea of deconstruct methods with value tuples. I think that was in C#8, I think. If you're not familiar with value tuples, they're way cooler than the tuples that have been around in C# and .NET for like forever. They have way better syntax and way better behavior and stuff like that. But one of the things that they added with those new value tuples is the idea of a deconstruct method. So sometimes you have an object or some package of data where you have several fields, several different fields that have data in them, and you want to explode that object back out into individual fields instead of being all put together in one object. That's what a deconstruct method is for. So like with a tuple, you're going to group two things together. Then you can deconstruct those two things back out into individual properties. With a record that has positional properties, you also get an automatic deconstruct method that will explode the positional parameters back out into individual variables. So like here I can say, hey, this object that I created right up here that has positional parameters, take those positional parameters and put them back into individual variables named string val and int val. So it'll take the first positional parameter and put it into this one, second positional parameter and put it into this one, and so on and so forth. If you have more than two positional parameters. And you can see this one does have the same value that I originally passed in here that matches here, and so on and so forth. So that's kind of cool. It gives you a nice, neat little package to put a bunch of values in, gives you nice, concise syntax to declare that, makes it immutable by default, and gives you an easy way to get those values back out again. One thing to note is that it does, with positional parameters, the compiler does generate a constructor for you, so you can't use object initializers like this with positional parameters. You can with records. We'll see that in a minute. But you can't with the positional parameters on a record. So that's something to be aware of. So depending on how you like to write your code, if you prefer constructors versus object initializers, that might be that might sway you for or against positional parameters. Okay, let's talk a little bit more. So that's the first thing. So with records, you can do positional parameters. You don't have to do positional parameters. You can do almost all the normal things that you do with a class. You can do the same kinds of things with a record. So for example, with this record type, you can see it is declared as a record, not as a class. But here I just have a normal property. I'm using an init setter like we saw up above. But you can use normal properties too. You don't have to use read-only properties like this. Records can totally have methods too. There's nothing saying you can't. You'll notice you don't get as concise of a syntax if you're adding some of these other, non-positional parameters. So this is much more concise syntax, or this one, I guess, is the one we really looked at. We'll look at this one in a second. But you can add any of these other things that you want to do that you would normally use in a class. You can mix and match the positional parameters and other types of properties. So like this one. So for just as an example, here I'm using positional parameters in my record definition, And I also have a method. I could have other properties if I wanted to. When I create a record of this type, I have to provide these positional values for these positional parameters. If I had other properties, I wouldn't necessarily have to provide values for those. But for positional parameters, I do still have to. So that's cool. We talked about that records don't force you to be immutable, but they do have some nice nice immutability features like positional parameters. Positional parameters are read-only by default. Well, I don't know if there's a way to not do it, actually. Another thing that works nicely with immutability and records is an idea, this idea of non-destructive mutation. So usually if you're doing immutability in codebase, if you can never change anything in your program, it's probably not a very useful program, right? So you have to change things sometimes. But how do you change things when everything's immutable? Usually the way you do that is you'll make an object that's all the things that you want, and then you'll want to change something about it. But rather than mutate the state of that object, you'll make a copy of that object, copying over everything from the original object except for the one thing that you want to change. So that way you have a new copy of an object with the change that you want. And you've been able to do, you can do that in C#. You've been able to do that in C# forever. You would, before C#9 and records, the general sort of way you would have to do it is you make this object, right? And say, okay, set all of my properties to whatever I want them to be, and then make a new object, change the one or however many properties I want to change, and then copy all the rest from the original object. Which, here we have two properties, and it's like, it's okay. It's not terrible. But you can imagine that this could get a lot more unwieldy if you have 5 properties or 10 properties or 20 properties or 100 properties or something like that, right? Every time you wanted to make a copy of this, of one of these objects, if you did it manually in code like this, you'd have to remember to copy all of the other properties and not typo anything. You could make some sort of helper methods or things like that that can do those copies for you, but that also gets a little unwieldy. However, with records, so you totally can do this without records and before C#9, but records in C#9 make it a lot easier. You can use this keyword with. So you take your initial record and you say with, and you do curly braces and give a list of the properties you want to be different, and will automatically copy over all the rest of them for you. So you just have to specify what's different. You don't have to specify everything else in the whole data structure, stuff like that. So that makes it really easy to just say, hey, I want a copy of this thing. I want this one thing different and everything else the same. Makes it really easy to do that. So that's really nice. In the past, I worked in a code base where it strongly favored immutability in the domain objects and stuff like that. But it was before records in C#9, and so there was this whole system under the hood to be able to say, hey, take this thing and make an exact copy of it, but change this one thing. It was super clever, super cool code, but it was not code I wanted to maintain. Okay, so non-destructive mutation, that's cool. Next thing with records we want to talk about is value equality. This is one of my favorite things with records. So say you have normal classes, a normal class, and you make two object instances from the same class, and you want to compare them to see if they're equal, right? If you use dot equals or double equals, by default with a class, the behavior you're going to get is reference equality, right? Do these two variables, these two reference variables, do they point to the same place in memory? I don't know about you. Usually that's not the behavior that I want. You can totally override that behavior. You've been able to override it forever. You can override the dot equals method on your class. You can even provide your own implementation of the double equals operator. You can do that, but you have to do it. right? And sometimes there are some nuances with doing that can be challenging. And so if you don't do it right, it can be error prone. Records are different. So here I have the behavior of the equals method and the equals operator is different with records than it is for normal classes. So here I have a record. I set some properties, right, to foo and 42. I have another record. This is a totally different record, totally different object in memory. It has the same values in its properties. And then I have a third record where one property is the same, but another one's different, right? So if these were normal classes instead of records, and I tried to compare them, they would all be different, right? Because they're all pointing to different places in memory. And if I compare the first record with the last one, you can see they're not equal, just like you would expect with a normal class, right? But it gets more interesting when I compare the first record and the second record. In this case, and if remember, I ran my unit test, so it's true, right? This is true. This first record is equal to this second record. So the rule is the two records, they have to be the same type, and all of their properties have to be the same. So, right, like since this record type has two properties, the string property on both objects has to be the same, and the int property on both objects has to be the same. Now, you may be saying, wait a minute here, this is dot equal to, that's not the equals method or the double equals operator. That's an n unit thing. It's doing something tricky behind the scenes, right? Okay, well, let's do the dot equals method. You can see if you do first record dot equals that second record, as long as the type of the record is the same and all of the properties are equal, it still results in true. It still evaluates to true. But I'm sure you're saying, wait a minute, well, dot equals, sure, but what about double equals? That's never going to work. And the truth is, it does. So they did it both on dot equals and double equals. And all I can say is, it's beautiful and it's about freaking time. Like this is the default behavior that I would have wanted from classes since C#1. So I'm super excited about this. This will make it so that I don't have to, if I want to compare two objects easily, I don't have to write my own equals or double equals and all that sort of stuff. With records anyway, it just works the way you probably want it to. Now, maybe you're saying to yourself, but wait, being able to compare the reference equality of two things is super important for me. You can still totally do that with records. You just have to do it explicitly. So for example, I have two records here. If I do dot equals, it's just like we saw up above. They are equal because they're the same type and all of their properties are equal. Here, in this case, I didn't set the properties, so they're their default values, but they do have the same values. If you want to do a reference equality, you can. You just have to manually do it, right? That's not the default behavior for dot equals. So yeah, that's pretty cool. The other thing that I'm most excited about with records, this is the technical term, non-sucky default toString. So anyone ever had this happen? You created a new class, you make an instance of it, and somewhere along the lines, you call toString on that object. What do you get? Something super wildly useful like this, right? Like the fully qualified class name, because that's obviously what I want when I toString an object by default. Now again, maybe there are definitely cases where that is a reasonable behavior, but to have that be the default, that's just not super helpful for me. You've always been able to override that behavior. You can override toString and have your own toString implementation, but like, why bother, right? Why do I always have to write my own toString implementation? With records, I don't. I have what I consider a reasonable, again, to use the technical term, non-sucky implementation of toString. So here I'm creating a record. I call toString on it, and what do I get? I get the non-fully qualified class name, and then curly braces and a list of property and value, which is what I want like 99.8% of the time. Like when I'm debugging or writing something out to the console or a file or something, this is way more useful to me than this. And all I can say is thank you, sweet mother of Abraham Lincoln. And lest you think I have some strange abnormal relationship with mother of Abraham Lincoln, that's a Toy Story 2 quote, in case you were wondering. Now you might be thinking, okay, well that's, this is a nice simple example. I just have a couple properties. How does it work on more complicated examples? The answer is it does work, though your mileage may vary depending on how complicated your record types are. So for example, I have this slightly more complicated record type. Here I have a normal property. Here I have a property that itself is another record type. And then here I have this string array, which I'm using as my example of not a record, an object that's not a record. So when I toString this one, you can see down here, I get the, again, non-fully qualified class name, great. Property, value. You can see here it's a little bit, it gets starting to get, because I have, I don't get any like double quotes around this value or anything like that. So the commas could maybe get a little bit confusing. For this property that itself is a record, you can see it just calls toString on that. And so it does the exact same thing as our simple record did, which seems reasonable. It is getting a little bit long here. So, if you have a whole bunch of things and very deep nesting or things like that, it might get complicated. And then if you have a property that's not a record or not a simple type, it's a class, you just get the normal toString behavior, which in this case is, not super valuable. But depending for these simple cases, works super well. And for these complex cases, depending on your situation, it can work well to reasonably too. And maybe there's a better, maybe if you really want to toString this one, it's time to write your own implementation. But at least you get what I would consider a reasonable implementation by default. Okay, so that is non-sucky default toString. The last thing we want to talk about with
hey, John.
records. Yeah.
Before we move on, I think
sure,
this
sure.
question was from back when you were doing comparisons, and not the automatic toString. But Dwayne on the chat asked, is there a performance hit for this type of code? It seems like the compiler is looking for things that match in memory. Is this going to add additional time? Oh,
that's a good question. If doing that comparison is obviously super critical to you, you'd want to time and make sure. I think I've read somewhere or heard in a presentation how it actually works. I don't remember off the top of my head. I want to say that it actually generates all the property comparisons in code, and so it's not like doing reflection or anything like that. But I could be wrong. So if that's important to you, you definitely want to do a little bit more research on that. I don't know off the top of my head.
Let's see if there's a follow-up here. He says, sounds good. I think I'll test it out later. So thanks.
Okay, yeah. Let us know in the Slack group what you find out. I'd be interested to know. Okay, and thank you for the question. Let's see. The very last thing we want to talk about with records, you may have been you probably noticed that we use the keyword record here, so the keyword class. You may be thinking, well, how does inheritance work with records and classes and stuff like that? The short answer is records can inherit from records. Records can't inherit from classes, and vice versa. So I kind of think of records and classes as, like cousins or something. Records can inherit from records. Classes can inherit from classes, but you can't mix and match. So yeah. So that's records, and that is C#9. So again, there are a lot of immutability things, a lot of nice to have things that maybe will revolutionize your code, like records, for example. I think will probably change how I write a lot of my code. Some of the other things, maybe they will, maybe they won't, kind of depends on your situation. but most of them are not nice things to have. Let's go talk about C#10. With a lot of the recent C# releases, versions, it's not 100% accurate, but oftentimes Microsoft kind of goes in a bigger release, smaller release, bigger release kind of cadence. And C#9 and 10 definitely fall into that sort of category. So I would argue that C#9, mostly because of records, is kind of maybe a little bit larger of a release, and C#10 is maybe a smaller release. With C#10, there are a lot of, most of the things we're going to talk about, it's like, oh, that's a nice to have kind of a thing. Again, things that may or may not drastically impact your code day to day. There are a couple of features in C#10 though that they maybe don't make the best presentation material. Like to do a presentation is like, oh, hey, you can do this now. Isn't that way better? It's kind of boring from a presentation perspective. But there are a couple things that have the potential to dramatically impact the way your code looks. The first one is global usings. Oops, that one. So in C#10, you can now add the keyword global to a using statement, and it, instead of applying just in that file, it applies in every file in whatever you're compiling. So usually in your project, right? So for example, I have this global usings file here. You can see I have, excuse me, I've added the keyword global before these using statements. If we come back here to my test, you'll notice I have exactly 0 using statements in this code, even though I'm using stuff that are using classes and things that are in other namespaces. That's because I'm getting those using statements from my global usings. Like, that's super awesome. I don't have to put using system in every single file, in every single C# file. I don't have to put using system.collections.generic in every single file. It's fine if I use a list wherever. It's totally fine. It's okay if I don't have to have a using system.link in every single file, every single C# file in my project now. It's fine if I use where or select or whatever. So and the nice thing is that rather than Microsoft just saying, well, we think all of these should be in every C# file, you get to decide, right? So whatever is important in your code base, if you're like, link, heck no, don't ever use that anywhere, don't put it in your global usings. But if you're like, yes, link all the things, please, then put it in your global usings and use it everywhere. So super awesome. This is one of those that it's like, oh, well, yeah, that obviously makes sense. Why did they not do that a long time ago? I don't know. They didn't get around to it, but I'm glad that they have it now. So that's one of those things that maybe doesn't make a great presentation item, but has the potential to dramatically impact what your code looks like, right? The other nice benefit is you don't have to worry about if your IDE supports collapsing using statements, because now hopefully you won't have 30 using statements that are the same in every single file. Along a similar vein is...
I'm going to interrupt you one more time. We got another question.
Sure.
For global usings, is the recommendation to put those in like main CS or in a separate file dedicated just to containing those using statements?
I have wondered that exact same thing. In the presentations and stuff that I've seen, I haven't seen any like, here's the C# standard convention for where to put global usings. In my limited use so far, I've created a separate file, though I didn't name this with C# conventions. I don't know why I did that. Get around to changing that before the presentation. I put them in a separate file, but you can put them anywhere. So I guess for now, just do whatever feels best to you. It'll be interesting to see if the .NET community, congeals around, well, this is sort of the standard way to do it. This is how it is in most projects. Or if it's just like, everybody does what they want.
Yeah.
So
I've only done two smaller projects, just kind of side projects using these new features, and in both of those, I basically did the same thing. I did a separate global usings file, just because I like to be able to find things fairly easy, and I don't want to have to hunt around to where those usings are. So,
yeah,
but that's just me.
Yeah. For me, having them in a separate file is what I've done so far, but I don't know. Maybe I'll change my mind later. So if you have strong opinions or thoughts on that, I would love to hear them.
And then one other question that I answered in the chat, but just in case I answered wrong, we got a question that says, can a record be serialized to something like XML or JSON with the built-in .NET stuff? I answered that I believe that's true. You can serialize records and classes essentially the same way. They behave the same way. Have you got any experience where that's not the case?
I haven't used it enough in like real world projects to know for sure. I played around with it a little bit, and I think I had the same experience as you, that it seemed to just serialize and deserialize just fine with like the built-in stuff or JSON.NET. But I don't remember for sure. But I think that just works.
Well, if anybody who's listening has any other experience with serializing records, feel free to post that in the chat where everybody can see.
Yeah, that would be great if anyone does have different experience.
Excellent. Back to file scope namespaces then.
File scope namespaces are another thing that I love in C#10. This is another one of those things that it's like, oh yeah, why didn't they do that forever ago? You'll notice maybe you already noticed in this class, things aren't indented like 12 tabs worth, right? Because this class isn't inside of a namespace with curly brace and indented like this one is, right? Here I have a namespace and it's a curly brace, and everything of importance in the rest of the file is indented, one tab. This one is not that way. I mean, you do have, this stuff is all indented because it's inside of a class, but it's better at least anyway, right? I don't have that extra indentation. That's because I'm using a file scoped namespace declaration. So you can now, instead of doing namespace name, curly braces, you can just do namespace, whatever your namespace is, semicolon. And that will apply to everything in that file. So if I had multiple classes in here, they would all be in this namespace. If I had other types, they would also be in this namespace. And in one of the presentations that I listened to, Microsoft said that they, scanned all of the publicly available C# GitHub repos, and something like 99% of all C# files only had one namespace in them. So they're like, oh, well, let's make that easy. If you do want to have multiple namespaces in a file for whatever reason, you'll need to use the old syntax with the curly braces, but you can still do that. It's totally fine. Both are valid. But for all those cases where you just have a single namespace in the file, you can do it this way and avoid a lot of needless tabs. So again, maybe not the most awesome presentation item, but it does have the potential to dramatically impact how your code looks. I would argue for the better. So those are the two things that I'm most excited about with C#10, and I think will probably impact the way my code looks the most. There are a few other nice little things. For example, I don't think I mentioned this explicitly, but the records that we talked about in C#9, those are like, you can't inherit from a class, but in most ways they work like a class, like they're a reference type. Sometimes you might want to have the goodness that comes with records, like positional parameters, the value equality, the Tostring stuff, but you want to do it with a struct. Maybe your code base is very dependent on value-based types instead of reference-based types. In C#10, you can have struct-based records. So you can see here, I can use a keyword record and the keyword struct, and then declare my struct just like I can use the positional parameters like this, or if I wanted to declare it like a normal struct, I could do that too. That's cool. Extended property patterns. We talked about pattern matching. They added this little bit of goodness for pattern matching in C#10. You used to be, so if I have this object and it itself has a sub-object in it. So you can see here I have a person and it has a name inside of it. Here I'm doing it with records, but you can do it with classes too. So here I have a person. I'll have a person object that has a name object inside of it, like this, right? With pattern matching before C#10, I could say, hey, I want to match on that person object. And then inside of that person object, go to its name property. And inside that object, do some sort of pattern matching. Here I'm just saying, if it's Fred or George or whatever, right? And matching that way. And this totally works, but it's a little bit more verbose. In C#10, they added what are called extended property patterns, where you can say, hey, I want to match on this person object, go to its name property, and then inside that object, go to its first name property and do a pattern match on that. So you can see here, these two, excuse me, these two pattern matching statements are functionally the same, but the syntax here is just a little bit nicer. So that's cool. Pattern matching, a little bit better. I won't complain. Constant interpolated strings, you'll probably either be like, this is awesome, this is the best thing, or you're gonna be like, that's dumb. So in C# you've been able to do string interpolation with the $sign for a little while, since I can't remember if it was C#7 or 8 where they added that. Been able to do that for a little while. In C#10, they added the ability to do string interpolation with constant strings. So you can see the string is a constant, and I'm doing string interpolation. Now, again, you might be like, yeah, that's the best thing ever. You're like, I don't know, when will I ever use that? Something to keep in mind, there are some rules around this. Everything that goes into a constant interpolated string also needs to be a compile time constant. So for example, this string up here is a compile time constant. And so it can be part of this constant string interpolation. And that works just great. One of the things, you couldn't have like an object or something in here, toString an object or something like that. That wouldn't work. Also, kind of disappointingly, even some other compile time constants you can't have in there. For example, if I did, const int value, even though this variable is a compile time constant, you can't do it in a string interpolated constant, because when you put this variable in here, the compiler will implicitly do a call toString on it, which is not a compile time constant. So even though the value itself, the variable itself, is a compile time constant, toStringing it is not. So again, this might be something that you're like, yeah, this is super awesome, or it might be something you're like, I don't know, when would I ever use that? If you have a code base that has a lot of, individual compile time constants, and you build them up to have larger strings and stuff like that, this might be something that's cool for you. Otherwise, maybe it won't revolutionize your code. Another thing in C#10, the record types can now seal the toString class, make it so that inheriting classes can't override toString. Yay, I guess. I don't know. I'm not the hugest fan of sealing classes, though it does have its place. And the last thing we're going to talk about has to do with deconstructors. So we talked about deconstructors with records. You can have a record and explode it back out into individual fields. In C#10, they made deconstruction a little, they added one little nicety to it. So let's see. So here, I'm going to, before C#10, if we had this person, this one's a record. If we had a person record and we wanted to deconstruct it back into individual variables, we can declare those variables beforehand and then deconstruct into both of them at the same time. That totally works. That was before C#10. This works with records and with value tuples or other classes. You can define your own deconstructor method on your own classes if you want to, and also this syntax will also work for your own classes. But the new thing, so before C#10, you can declare the variables and then deconstruct into them. Or here's an example with a value tuple. We declared the variables beforehand and then deconstruct into them. You can also declare the variables and deconstruct into them at the same time. That's also an option that works with tuples or records or your own type. All of this is pre-C#10. The thing that they added in C#10 is sometimes maybe you want to declare some of the variables that you're deconstructing into beforehand, and some of them when you're actually doing the deconstruction. Now in C#10, you can do that. So you can mix and match. That's the thing that they added, which again, I don't know, I probably won't use that a lot, but I can see why it would be nice to have that.
Hey, John,
yeah.
On line 130, would you want that assert to be name 3 dot first name
Name 3
instead of name 1?
Yeah. Why did I do name 1? I don't remember why I did name 1. That might be a copy paste thing. So yeah, probably I want to do, let's see, what did I name that guy? I don't know why I did name 1. Probably want to do name 3 like that. Then just to prove that it really still passes. Oh, it didn't. Oh, it's because this is a name. I'm sorry. I was doing name 3 dot first name like that. Yeah, that was probably a copy paste error. Thank you for catching that. So yeah, with that, that's most of, again, as I mentioned, that's not every single feature in C#9 and 10, but it's the ones, it's most of them and the ones that I thought were the most important. So hopefully these were useful for you. There are also features that are in the newer versions of .NET that aren't C# specific. For example, like in, I can't remember if it's .NET 6 or .NET 5, they added, we've had date time classes for forever. There's now a separate date class and a time class if you just want date and just want time and things like that. So anyway, there's a lot more learning and investigation to do and stuff like that. But hopefully this was useful to you. If you were already familiar, hopefully it was a good review. If you weren't familiar, hopefully you learned a few things. You're like, oh, that's cool. I want to go play with that. I want to go try it out. And if you do, again, if you want to use this code base, that's great. Please go download it and play around with it. If you want to do it on your own, that's in your own code project. That's cool too. Yeah, and that's it.
So John, we had one other question that we got missed dealing with pattern matching. Jake asked, does that pattern matching deal with null references? And if you have a specific issue about nulls or something, Jake, if you want to unmute and expand your question at all, you're free to do that as well.
And your C#10 example for pattern matching, you can do name dot.
Oh, right.
Name dot whatever first name in there. But if name is null, does it deal with that, or is that something you still have to deal with yourself?
I'm guessing you'd have to deal with it yourself. I think you could do another.
Those are my Valentine's.
I think you can do another pattern in here where you can say like name.
You won't need them till Valentine's Day.
And have that go to something. But I think I don't know for sure, but I think this one would not handle the null. I think it would throw a null reference exception is my guess, but I don't know for sure. You could also do a hook dot here, like that, if you wanted to. In this particular case, this is non-nullable, so it won't work. But yeah, that's a good question. Any other questions before we're done? Before I'm done? I don't know. You guys can keep going.
That's all we had in the chat. So I mean, if anybody else has any other questions, you're free to unmute and ask now.
Let me come back over here in case anyone wants to get the link or the QR code again.